Good morning all. Myself Jayeeta Majumder, Associate Professor of Department of Computer Science and Engineering of Haldia Institute of Technology. Today I am presenting my video lecture on the topics of Basic of Computer Networks. So on the following slides, I will discuss what is network, what is the different link, basic overviews of these networks. So first, the term comes the data communications. So here actually two words is there. One is data, one is communication. So first, what is communication or telecommunication? So the term telecommunication means the communication at a distance. That is when two devices or two nodes or two people, two entities actually, at different places, how they communicate, actually it means communication or telecommunication. So and the data means the information presented in whatever form agreed upon by the parties creating and using the data. That is, data may be inside the letters or numbers or picture, audio, video, anything. Whatever you want to transfer or whatever both the parties, that is the sender parties and the receiver parties, mutually understand, that is this is shareable between them, then it is treated as the data for communication. So data communication totally known as the exchange of data between two devices via some form of transmission medium such as wire cable. Here what term is introduced, that is the transmission medium. So transmission medium means the way, the path by which the data is communicated from one end to another end. So here one example I discuss here, that is the wire cable. That is the cable, that is the line. Sometimes it is wireless also. So the transmission medium, through some transmission medium, when the data is exchanged between two parts or two devices or two people, it is known as the data communication. So to perform any data communication, we require 5 components. This is the basic 5 components. So what are the 5 components? In this diagram, here the 5 components is discussed. The first one is sender. Sender means the source end, that is who send the data to the other end. Second one is the receiver. Receiver is none other than who accept the data. That is, when sender sends the data, after some time, after some delay, that is the receiver accept the data. So the second party is the receiver. Third component is the medium. Medium is by which the data is transferred. That is, either it is physical medium or it is some optical medium, anything. That is transmission medium. It is either cable or wireless. Okay. So this is the transmission. The deadline is the transmission medium. It is established between sender side and the receiver side. Fourth one is the message. Message means the data, whatever you want to transfer. That is in the form of either data, numbers, alphabets, numeric, audio, video, anything. Whatever you want to transfer to the receiver side, it is known as the messages. And the most important, the fifth one is the protocol. Protocol is nothing but some set of rules that is maintained both by the sender or the receiver, as well as the total system is that particular rules is maintained. So this is the protocol, the some set of rules that is previously assigned or before data communication, before the communication, this protocol is fixed, okay, by mutual understanding. So these are the 5 components to transfer a data from one side to another side: sender, receiver, medium, the messages or data, and fifth one is the protocol. Now in the next slide, here the different data flow techniques, data flow, how the data transferred, the flow mechanism is discussed here. The first is the simple, there are 3 types of data flow techniques. First one is the simplex, second one is the half duplex, third one is the full duplex. Three types of data flow in data communication. There are three diagrams A, B, C. The first one is the simplex. Simplex is, suppose mainframe with that computer or that node is the sender side and monitor that one is the right side is the receiver side. So here you check, that is the direction of data is one side, that is the one-way direction. So only the left side, that is the mainframe computer, only sends the data to the right side, the monitor end. But monitor cannot send the data to the mainframe. So this is the simplex way. That is only one can send the data. Okay. So this is the direction of the data. The real life example of data flow or simplex type of data flow, you know, the television or the radio, that is only the television when broadcasting some serials or the news, that is only that side, the server side or the television station only sends the data to our side, but we cannot send the data through the television end. Okay, so this is the example of the simplex. The radio is also, that is the radio station only broadcasted the data, but we cannot send the data simultaneously. Second one is the half duplex. Half duplex is, as per the diagram, you check both the station is present, sender station and receiver station. Two direction is also present, that is both way direction, but the time instance is different. That is simultaneously or parallel at a single instance of time, both the end cannot sense the data. If time one slot, first time slot, the station left side station sends the data to the right side station. In the next time slot, if some data required to send from that side, it sends the data to the other end. Okay, so this is the time one's first time slot send, this is the second time slot send. So at the single instance of time, only one station can send the data, but that time station 2 hold. After completion of the sending data, the second one sends the data. The real life example, very few years ago, some electronic devices, there is the pager system or the walkie-talkie. Most important is the walkie-talkie. That is the policeman or the traffic police, that is the sales or army people say talking over the walkie-talkie. That is the only sense, that is hi, this is the I am here, I am in this station. Over means that time is end. Then the next side sends the data and he only listen. Okay, so that is the Wi-Fi concept. That is one person sends the data, one station sends the data. That time the second station holds some time, and then after completion of that station, he revert back. Okay. And the third one is the full duplex mode. That is some modification obviously in the half duplex mode. That is simultaneously both the senders, that is single instance of time, both the senders is applicable to sends the data. That is the station 1 when sends the data, at the same time station 2 or the receiver side also sends the data. Okay, so both sides simultaneously or at a single instance of time it sends the data. So in modern days, that is a mobile phone, or when I talk with someone, that is hi, hello, how are you, at the same time he also communicate with me, that is hi, I am fine, and this. Okay, this is the station full duplex mode. So these are the data flow techniques. How many types of that categories of data flow techniques in our communication system? Now the terms comes networks. That is computer networks. So networks. So first we discuss what is the definition of, that is the formal definitions of computer networks. A network is a set of devices. Here sometimes device is also declared as nodes. Okay, so that's why it is referred to as nodes. Connected by communication links. It is also important. So that is when more than one devices or set of devices connected via some communication link, either it is wired or wireless, anything, but some link is present between them or among them. So that is known as the networks. Okay. A node can be a computer, printer or any other device capable of sending and or receiving data generated by other nodes on the network. Okay, computer, printer, we know that is if it is computer based network, it is declared as computer network. Suppose I am a human being, you are also human being. So both the human being also passes the data with some messages or verbal communication. It is also a network. That is, I connected with you some verbal communication. So this is that is the human communication or human networks. So similarly, if different computers are connected with some communication link, it is known as computer network. So that is computer, printer, any other device capable of sending or receiving, both side nodes are computer network. So here different type of connection, how the particular connection, that is the link, is established. So according to computer networks, there are point to point and multi-point. So point to point is here, point to point, that is single instance, so that is station 1 and station 2, that is both sides, sender side, only one present, one sender, one receiver. So and one single link is present, so this is known as the point to point. Now when multi-point concept comes, here you check sender side is 1, but in the receiver side there are 3, according to a diagram, 3 station is there. So that is the 1, 2, 3 stations with some communication link, that is that particular data whatever sent by the mainframe, it is shared by station 1, station 2, station 3 and more. Okay, so that's why it is known as multi-point. This is the tap point, that is the communication point, and then it is connected. Now one term is there, that is the topology. Topology is nothing but the term, that is geometrical connection between the station and nodes. Okay, the geometrical structure. Okay, how the nodes are connected, how they are looks like in our system, it is known as topology. So there are also some classifications or categories of topology. First one is the mesh topology, then star, then bus, then ring. There are more common. These are the 4 common topologies. Besides this, there are tree topology, hybrid topology, both are all are present. So common topologies are mesh, star, bus and ring. So first start with a diagram shows, that is the mesh topology. Mesh means a net. Okay. So here a fully connected mesh topology with 5 devices or 5 nodes is in the diagram. So suppose these are the 5 stations, 5 nodes. Here you check all the stations are connected with each other. So that's why it is declared as fully connected topology. That is station 1 connected to station 2, station 1 connected to station 3, station 4, station 5, in this way station 2 also connected with each other. So these are here fully connected. It is not fully connected, if not then some of connection is lost, but all are connected with each other. So these are the fully connected mesh topology. Next, the bus topology. This is the easiest one. Bus means a series. Okay, link, a series line. So suppose one cable is present there, that is the transmission media. The cable is called here the transmission medium. So that is the cable. So at the tap point, some station is present. Here 3 station is there in the bus topology. The connecting point is known as the tap, and from the cable, main cable, that is the transmission medium to station, that line is declared as drop line. So that particular station is connected via tap point with the cable. So main data transfer from this cable, and as per its requirement, it collected the data from the tap point using the drop line. The station 1 collected the data. So these are the bus topology. Next one is the ring topology. So ring, whenever we think ring means a circular concept. So circular concept, here the diagram of the ring topology. That is the station, both sides 1, 2, 3, 4, 5, 6, total 6 station. One ring is there. ring is treated as the communication line. Okay, and here the tap point, in case of bus topology is tap, here it is the repeater who repeats the data. So suppose why it is repeater, what is the drawbacks of this line? Suppose this is repeater station 1. Station 1 wants to send the data to station 3. This is station 2, station 3. It transfers the data through the line, but if station 2 tapping at that point, it get the data. But then station 3 collected the data when it is required. So unfortunately, all the data is shared by all the stations. So this is one drawbacks of this ring topology. But this ring is looks like a ring and the connected with different stations. Now one topology I here discussed, that is the hybrid topology. So the name is hybrid. So there are two topology is merged. One is here the star, another is a bus network, and another is a bus. So star means is nothing but how star looks like, one center position and the other is there. So suppose star looks like in this way. It is a star. So the central point is declared as the hub and rest of the position is the station point. Okay, so this is the star topology. The central point of the star is declared as the hub. Okay, and hub has different interface, and that particular interfaces we connected some bus topology. So the first port is connected with the bus line number 1, then the second one, then the third one. So these are the complete hybrid topology with star and the bus. Now the most common term is there, that is the internet. So the internet is known, that is our daily life. It is very much useful in modern days. So it affected the way we do business as well as the way we spend our leisure time. Every time now in our modern days, internet is bigger. So internet is nothing but a communication system that has brought a wealth of information to our fingertips and organized it for our use. So internet, when I think internet, first mind is come from Google. Google is not the internet. Google is a browser from where we find the data. Okay. So, but the connection established with a phone or mobile phone or desktop to the Google server, it is required the internet. If your line net connection is off, then we cannot connect the Google server to a mobile phone. Okay, that's why this is any server, output server is connected with your fingertips, it is required the internet. Now protocols discuss, that is some protocol is the synonym, some rules. That is every time when we communicate or when we transfer data, it requires some set of rules. We obviously followed that rules. Now, to implement the communication, some standard model is required. First one is the International Standard Organization, the ISO. It is a multinational body who actually implement this. ISO OSI model is introduced. So ISO is the organization, OSI is the model. So OSI is nothing but that is there are 7 layers. The total communication layers are divided into this: physical, data link, network, transport, session, presentation and application. This is the total diagram of the interaction. So at the bottom physical to physical connected, then data link, application, the user are present in the application layer. So one by one each layer is connected, then data physical communication, physical end to physical end, then back to the application layer. The exchange of the data, that is the first one, sender side sends the data D7 D6 to this side. This is the data through transmission media again back to the receiver side. So physical layer, here data in terms of bits, that is from host to host the data is connected. In data link layer, one node to the next node with some header and footer from frame. Here the data is terms as frame, that is collection of bits, it is declared as frame. Network layer, here the data in terms of packet. So one packet is transferred to the next layer. Transport layer, there is message in terms of process. That is different process is connected with different layers. Now session layer, the dialog control, the presentation layer, transport layer, and the synchronization, that is the data, how the data is synchronized here, that this particular layer is maintained. And finally application layer, where the service provider is there, that the user is there, some application program is running at the application. Summary of layers, that is a physical data link network in this way. Application layer allow the access to the resources. Presentation layer convert the data into complex data. Session layer establish, manage and terminate the session. Provide process to process management. Move packet from source to destination. Data link bits into frames, and finally physical layer bits to over the media. And another protocol also maintained, that is a TCP/IP protocol. This is not exactly matched with the OSI model. It is there are actually physical data link network transport application. Total 5 layer is there. Physical data link, here the IP layer, transport, session, application and presentation layer is combined there. Okay, so this is the TCP/IP model. It is the total, this black side is the OSI model and this side is the TCP/IP model. And some addressing also there. There are 4 levels of addressing in internet. So physical, logical, port and specific address. These are the address classification. Physical address change from hop to hop, but the logical address, port address are usually remain same. So our port address or logical address, it is fixed for our system, but physical address may be changed when it transfer from one hop to another hop or one node to another node. This is the, so physical address basically working on this layer, physical layer, data link layer. Logical address is in the IP layer or network layer. Port address working on the transport layer, and finally some specific address in the application layer. And communication requires some security, obviously network. So network security, there are 5 services when we message transfer from one sender side to receiver side. Some security service is required. First one is the message confidentiality, message integrity, message authentication, message non-repudiation, and finally the entity authentication. So all the first 4 is related with the message, the data, and the last one is the entity, that is the party side. Okay, so if I am not authenticate with you, it is not the reliable transfer. And message side, it is required for, obviously message is confidential, message is integrate, message is authenticate, and finally message is non-repudiate. So this is the 2 types of communication. One is symmetric key communication, one is asymmetric key. So first one, how to create the confidentiality of the message. So both sides, suppose Alice and Bob are 2 users. So Alice and Bob sends the data with some shared key. That is, a single key is shared both sides. One side used for encryption and second one is used for decryption. Similarly, shared secret key but different. So 2 keys is there, but both sides is shared. Key is shared in both sides. One is used for encryption, one is decryption. But in case of asymmetric key, so that key is different. One key, different key. One key, actually it is known as public key and private key. So one key is used for encryption. Another key is used for the decryption, but previously known by 2 parties. So similarly, encryption, here the first diagram, Bob's key is used in Alice Bob communication. Here Bob's, that is the right side key, is used for both sides. Here Alice key is used for, Alice public key and private key, both are used for the encryption and decryption. So here are some basic of the computer networks we discussed in this session. So hope you understand, and thank you.